1.4, building functions from functions. All right, so sum, difference, product, and quotient of functions. Let f and g be functions with intersecting domains for all. Okay, just refresh on that symbol. For all values of x in the intersection the algebraic combinations of f and g are defined by the following rules. So I'm going to do it for each one. So for sum, f plus g of x is equal to f of x plus g of x. For the difference, f minus g of x is equal to f of x minus g of x. For the product, f times g of x is equal to f of x, g of x. And for the quotient, f divided by g of x is equal to f of x over g of x, given g of x is not equal to 0. Okay, so that's for sum, difference, product, and quotient. Okay, those should be relatively self-explanatory. Next we have the composition of functions. So we're going to let f and g be two functions such that the domain of f intersects the range of g so the composition is f of g, f with the little circle, g, okay, it kind of looks like fog. Okay, this isn't the multiplication symbol, this is a really small little o. Okay, I'm just putting them in quotes so you can see what they look like. Defined by, and this is how they would actually be written on paper, little fog, okay, of x is equal to f of g of x. So that means in f of x, anywhere you see an x, you're going to put g of x. Okay, so I'm going to draw a little picture down here. So I'm going to have x here. I'm going to have g of x here, and there's no rhyme or reason to the shape that I'm drawing. It's just for fun. This is f of g of x. Okay, so the way this works, I'm going to draw arrows. So it goes x to g of x, and this is g. It goes from g of x to f of x, and I forgot to draw my little point here. Or I can go all the way from x over to f of g of x this way. Okay, if the picture is confusing, you don't really have to worry about it. I'm just trying to show you a little visual of what's happening. Okay, and then I'm going to write a little bit below here. X must be in the domain of G. G of x must be in the domain of f. And I promise if this is confusing, it will make more sense once we do some examples. Okay, you may want to pause this here and get this picture down. I'm going to keep going just so that the video is not ridiculously long, but if you didn't get it down, you may want to pause the video here and do that. Alright, and then lastly, we've got decomposition of functions. Okay, so it's just the opposite of the composition of functions, which we just looked at. Reverse of composition, or composing, I guess I should say. Functions. So it's the breaking down of a larger function into two smaller functions. So you'd be given something like f of g of x, and you would need to figure out what g of x is that is in f of x. And lastly, a relation is a general term for a set of ordered pairs. And again, all of this will make a lot more sense once we do the examples. So if it sounds confusing, I promise once we get there, it won't be that bad. It's actually kind of fun.